start our discussion. So today we are going to discuss about drying, factors affecting drying, and different equipments used in the drying will be discussed. So in previous classes we have discussed something about drying, like the difference between the drying and distillation, drying and evaporation, and all. Generally, in drying, in single line, if I want to answer, less amount of water is being removed. So generally, to remove the less amount of water or traces of the water, we use drying. And the final product of the drying will be always a dry product, a free flowing product generally. So this is what happens. And even in drying, we generally employ heating as a source. So there are a lot of objectives of drying, and there are a lot of factors affecting drying. First, let's focus on objectives of drying. Generally decreases food decomposition because presence of moisture, water vapor, and water increases the chances of decomposition. So decreases the food decomposition by drying, and you can also prevent the decomposition because of drying, as microbes, right, cannot be survive long enough in dry products. And it makes transportation easy because weight of the product will decrease drastically, and it is used for reducing transportation cost, again the same thing. And during granulation, during tableting also, these dried products are important, right? So storage cost can be prevented, and many other uses are there in the objectives of drying. So one thing you should remember, that stability increases because of drying. So that is the major thing, by preventing or by overcoming the microbial contamination. Let's see the next important thing, that is applications of drying. We can see that during preparation of bulk drugs, we undergo drying. We undergo the technique called drying. Dried aluminum hydroxide mixture, spray dried lactose. This is a very important diluent, very important diluent used in direct compression of tablets, spray dried lactose, and powder extracts and other preparations of bulk drugs. We are going to use this thing. What can we say? Drying products. Then you can see preservation of the drug products. We are going to use drying, improved characterization, free flowing properties. For some, we can use drying, improved handling. We go for the drying, reduction of the transportation cost. We'll go for drying, purification of crystalline products. This is the important part. We'll go for drying, and marketing specifications also. Dried powders, dried peppers, dried, like many other food products are available to increase the storage time and shelf life. All these things are the applications of drying. We need not to focus much on it. The most important thing in this class is factors affecting drying. So this is again an important part we need to discuss. What are the different factors which affect drying? Particularly, what happens is particulate diameter can affect the drying. The bigger the particulate diameter, the lesser will be the surface area, and it will take more time to remove the bond water from it. So the smaller the particle size, the easier will be drying. So this is one of the major factor we should remember. Then mechanism involved in drying operation. There are a lot of equipment used in drying, and the mechanism involved in drying operation, it changes, then the rate of drying also changes. Size uniformity is also one of the factors which affect the drying. Physical properties like wet and dry solid particles affect the drying. Product mass flow is one of the, flow rate is a factor of drying. Hot air mass flow rate is one of the factor of drying. And very, very important, dry diameter of the dryer section. The larger the diameter, the bigger the surface area of drying, the more efficiently drying takes place. Then critical moisture content, CMC of the material. See, critical micellar concentration, CMC, is different. Critical moisture content here is entirely different. So these are the factors which are going to affect drying. Please note down: particulate diameter, mechanism of drying, size uniformity, physical properties of wet and dry particles, product mass flow rate, hot air mass flow rate, And diameter of the dryer section, diameter of particle is also a factor, diameter of dryer section is also a factor, critical moisture content of the material. These are certain factors which are going to affect the rate of drying. Now let's jump into the very important concept, mechanism of drying, how drying is taking place. Drying is discussed under the two heads, basically equilibrium relationship and rate relationship. These two things should be understood to understand the mechanism of drying. So drying mechanism involves different stages and is dominated by different mechanisms. కొన్నిట్లో equilibrium relationship is important, కొన్నిట్లో rate relationship is important. So what is equilibrium relationship? Equilibrium relationship లో please note down the main topic you should remember is EMC, equilibrium moisture content. ఇందాక CMC అన్నామండి, critical moisture content. Now I am saying EMC, equilibrium moisture content. Okay. So what is EMC? What does it signify? EMC is the amount of water present in the solid exerting a vapor pressure equal to that of surrounding atmosphere. So this is EMC, amount of moisture content. Please note it down. EMC, amount of water content or moisture content in a solid exerting a vapor pressure equal to the surrounding atmosphere. So equilibrium moisture content is a moist substance as shown in the figure. You can see here, right? Amount of water will be equal to the moisture content. So this is EMC. Then what does that exactly mean? Temperature and humidity of the air to which the substance is exposed are kept constant. Temperature is kept constant here. Humidity is also kept constant. And the substance either absorbs or loses the moisture depending on the flow conditions. So two things here happens. One is desorption, other one is sorption. Desorption, when a substance containing moisture more than EMC, remember moisture more than equilibrium moisture content, then it is exposed to air of constant temperature and humidity. It loses water till it attains the EMC. This is called desorption. Well, the moisture is more than EMC, we will heat until the moisture reaches to EMC. That's called absorption, desorption. Then what is sorption? When the substance contains moisture less than EMC. See, moisture less than EMC. Then what we are doing? It's exposed to air containing humidity and it is allowed to absorb the humidity until it becomes equal to EMC. This option antunnam. If you are allowing the R formulation, R powders to absorb the moisture content, it's called sorption. If you're drying it to remove the moisture content, it's called desorption. And desorption now you are drying it to remove the excess of moisture and making it equal to EMC. And sorption, you are allowing it to absorb the moisture until it becomes equal to EMC. So that's the major difference between desorption and sorption. I'm repeating again, what is equilibrium moisture constant and the equilibrium moisture content is amount of water vapor present or present in solid. Solid means any two drug which we are drying exerts a vapor pressure equal to that of surrounding atmosphere. Then equilibrium moisture constant is a moist substance. So its moisture should be equal to atmospheric moisture. Then we are calling EMC, equilibrium moisture constant. Okay. So how to measure EMC? You can see the graph here with the relative humidity on x-axis, moisture content on y-axis.
Relative humidity.
Yeah. So how EMC is measured? The value of EMC can be determined by plotting a graph between the moisture content on x-axis, moisture content on y-axis, and relative humidity on x-axis. The sample are placed in a series of closed chambers, such as desiccators, for maintaining fixed relative humidity in an enclosed airspace. When the samples are exposed to varying conditions of humidity till equilibrium is attained, then these samples gain constant weight. So moisture content is the difference in the final weight and initial weight. In just a minute, I'll take a sample, take the initial weight, then I'll add it in the desiccator. What will happen in desiccator? Moisture is constantly absorbed and the moisture is constantly removed and the weight of the product decreases. So then final weight minus initial weight gives me the how much of moisture is being absorbed. So that will help me in calculating the EMC. Now placing the percentage relative humidity on x-axis in the Gipurna and moisture content, how much weight decrease is that is the moisture content. On y-axis, an equilibrium moisture curve can be plotted. Got it? I'm repeating again. What you're going to do is you're taking a, like, for example, a Petri plate and you're adding a slurry of calcium carbonate. We'll do in this in practicals. మీకు గుర్తుందో లేదండి ఎప్పుడో చిన్నప్పుడు చేశారు కాల్షియం కార్బోనేట్ CaCO3 ప్లస్ వాటర్ స్లర్రీని మిక్స్ చేసుకుంటాం. సో ఆ స్లర్రీలో ఎంత వాటర్ ఉందనేది యూ నో దిస్ బికాస్ యూ యాడెడ్ ఇట్. బట్ జనరల్లీ వాట్ విల్ డూ like ఒక liquid substance ఉంది. So now I will subject this substance or this Petri plate to drying in a sense not in a dryer but in a desiccator. సో డెసికేటర్ లో కాన్స్టెంట్ కండిషన్స్ లో డ్రై చేస్తే ఏమవుతుంది, ద ప్రోడక్ట్ ఈజ్ ఎవాపరేటెడ్. సో ద ఇనీషియల్ వెయిట్ కంటే కూడా ఫైనల్ వెయిట్ ఐ గెట్ లెస్. సో హౌ మచ్ వెయిట్ ఈస్ డిక్రీజ్, the decreased weight is the amount of water vapor escaped or the amount of moisture lost. That is the moisture content. So plotting a graph by taking relative humidity on x-axis and moisture content. Moisture content is amount of weight lost or amount of weight of water vapor decreased after storing it in desiccator. Right? If you plot these two, you will get the EMC graph. Clear? Is it clear? Can we move forward?
Yes, sir.
Thank you. Then factors affecting EMC. So there are a lot of factors which affect the EMC. One among them is the nature of the material. Like non-porous insoluble substances have zero EMC. You should remember this. If the substance is non-porous, if the substance is insoluble, then there will be no EMC at all. The technical example for that is talc. Talc has zero EMC. Fibrous substances, colloidal organic substances have the high EMC value. Porous substances, much higher in value of EMC. So the water may be held in these fine capillaries present in the interior of the substances. So ఇది nature of the material గుర్తుపెట్టుకోవాలి. Insoluble non-porous substances will have zero EMC. Porous substances will have higher EMCs. Nature of the air. Substances exposed to humid air and non-humid air, the values will be different. In humid air, zero EMC values are seen, and in exposed to the air of increased temperature have decreased EMC values. So nature of the air is also important. EMC of solid is constant value given temperature of humidity of air. So equilibrium curve reaches up to 100% relative humidity. The moisture content obtained will be EMC with the saturated air. So if the type of the air, nature of the air changes, then the EMC will be affected. So the next important term you should remember is FMC, free moisture content. It is the amount of water that is free to evaporate from a solid surface. It's called free moisture content. Free moisture content is total water content minus EMC. Total water content minus EMC is called FMC, free moisture content. Please note it down. What is FMC? FMC is the total water content minus EMC, or the amount of water that is free to evaporate, ready to evaporate, unbounded water in the molecule details. Okay, so this is what we need to remember here. Then one more very important thing you should remember is percentage loss of drying, LOD, how to calculate loss on drying, mass of water in sample, by total mass of wet sample into 100 will give me the LOD, loss on drying. Will give me the loss on drying. Please note down this formula. Please note down this formula. We have discussed the moisture content. We have discussed EMC, equilibrium moisture content. Now we are discussing about percentage loss on drying LOD, that is mass of water in sample in kgs by total mass of wet substance or wet sample into 100. Now the next
Sir,
important formula is moisture content MC calculation. Mass of water in sample by mass of dry sample into 100. And example, 30 grams calcium carbonate slurry taken. Then you added 10 ml of water in it. So mass of water sample is 10 ml here. Mass of dry
Hello,
sample is 30 ml here into 100.
hello,
Yes,
sir. This is Shivakrishna, sir.
yes, please.
సారీ టు సే సార్ నేను కొంచెం నేను ట్రావెలింగ్ లో ఉన్నాను బట్ క్లాస్ వింటున్నాను.
Okay, no issues.
నోట్స్ రాయలేను అంటే మీరు చూపిమంటే చూపించలేదని అనుకోవద్దు. సారీ సార్.
Okay, okay,
ఓకే, థ్యాంక్ యూ.
welcome. So I'm saying with an example, if we take 30 grams of calcium carbonate slurry and add 10 grams of or 10 ml of water in it, then a mass of water sample will take 10 ml by mass of dry sample 30 ml into 100 చేస్తే నాకు percentage moisture content వచ్చేస్తుంది. Okay, this is how to calculate percentage moisture content. Then drying rate, very very important. How to calculate drying rate? Weight of the water sample. So weight of the water sample in this case, then 10 ml అన్నాను కదా, 10 వేసుకోండి. Then by time taken in hours into weight of the dry solid. Complete dry చేయడానికి ఎంత టైం పట్టింది, ఆ వచ్చిన వెయిట్ ఎంత. This will give me drying rate. Please note it down. Drying rate. Drying rate is weight of the water in sample by time into weight of the dry solid. Time is taken in hours. So this is drying rate. So we have seen three formulas. Loss on drying, LOD. Loss on drying is mass of water in sample by total mass of the wet sample into 100. Then moisture content, we discussed mass of water in sample in kgs by mass of dry sample in kgs into 100. Then we discussed drying rate, weight of the water in sample by time into weight of dry solid. Okay. Next, drying rate curve. Just observe the drying rate curve. What's there? What we are taking in x-axis, free moisture content. What we are taking on y-axis, drying rate. So free moisture content and drying rate, both formulas we have, right? So we'll get a graph in this fashion. And what does this graph mean? See, from A to B, it's an initial adjustment. B to C, it is constant rate period. And C is the critical point here. From C to D, you are getting first falling rate period. And then from D to E, you're getting equilibrium moisture content. So this is parts of drying rate curve. Okay. So A to B, it's an initial adjustment period. What's happening in initial adjustment period, which corresponds to the time during this period heat is absorbed by the surface and the temperature is being increased. As a result, moisture evaporates and begins to cool the dried solid. When the heating and cooling rate equalizes, the temperature becomes stable and is equal to the wet bulb temperature. This state name on the initial adjustment state in drying rate. Next is B2C. What is B2C here today? Constant drying period. What's happening in this period? First falling rate period, constant drying period corresponds to the time during this period the temperature of drying rate are kept constant and diffusible process occurs in which the water from the interior of the substances replaces the moisture vapor from the surface. సో లోపల నుండి మాయిశ్చర్ బయటకు వస్తుంది. The diffusion rate and the evaporation rate are equal at this point. At the end, the constant rate, moisture constant, critical moisture content CMC is seen. This is the second stage, this one. Then third stage and from C to D, falling rate period. In this period, what's happening? Unsaturated surface drying corresponding to drying corresponding to time during the drying, the replacement of surface water occurs in the slow rate. So maintaining continuous film on the surface. So this is a second critical point, that is D, this one. Second critical point. Then see what's happening. From D to E, second falling rate corresponds during the period. The decline of the drying rate is faster than that in the first falling rate. So here what's happening? The drying rate depends on diffusion rate of moisture and the point E is equilibrium moisture constant. So the idea kosam and the parts kosam, the thing to be focused is the equipment. So we have discussed rate of drying curve low A to B ఏమైతుంది, B to C, C to D and D to E we are seeing. Point E is the equilibrium moisture constant. Point D, second critical point. Point C, critical moisture content. Right. Point A is to B to C is constant rate period, and point A to B is initial adjustment period. Initial adjustment period లో లోపల moisture బయటకు వస్తుంది, some surface area cool down అవుతుంది. Right. Then constant rate period లో it's becoming equal. Right. The rate of diffusion and rate of evaporation are equal. And in falling rate period, the rate increases, rate of drying increases, and it continues after the critical period. So this is the drying rate curve. So CMC, FMC, EMC చూసామండి ఇప్పటిదాకా మనం. CMC is critical moisture content. CMC, we are seeing this point. Point C is CMC. Point E is EMC. Equilibrium moisture content. FMC గురించి కూడా చదివాం మనం. FMC is free moisture content. Now we are going to see further new things, that is critical free moisture content, CFMC. ఇప్పటిదాకా FMC వచ్చింది, free moisture content. ఇప్పుడు CFMC అంటున్నాం. If the moisture content present at the end of the constant rate period, this moisture content is low for non-porous material like sand and high for the colloidal substances. CFMC, FMC, EMC, CMC. Now, EMC already discussed. Equilibrium moisture content is the moisture content present at the end of the falling rate period. Percentage moisture content, already formula we have wrote. Moisture of the water sample, mass of the water sample, mass of dry air into 100. ఇక్కడ చెప్పుకున్నామండి already said. Just have a look again here. Yes, moisture content. So again the formula is repeated here. Drying rate would already be discussed. Weight of water sample into by time in earth by the weight of dry solid. Should have been already discussed here. Right? So these two things already discussed. So this is about drying rate curve. ఒక్కసారి చూసుకోవాలి. Next, the very important concept of today's class is drying equipment. ఇందులో చాలా ఇంపార్టెంట్ ఎక్విప్మెంట్స్ ఉన్నాయి, నార్మల్ ఎక్విప్మెంట్స్ ఉన్నాయి. We will stress on important equipment. So coming to see dryers, there are a lot of dryers available here, like rotary dryer, rotary drum dryer అంటాము, right? Hand dryer, spray dryer is one of the very important equipment after fluidized bed dryer. It will be the one of the crucial equipment. So I'm highlighting it. See, spray dryer is one of the very important dryer. Freeze dryer is next important equipment to be remembered. And FBD, fluidized bed dryer. ఈ త్రీ చాలా ఇంపార్టెంట్ అండి. స్ప్రే డ్రై because they are used a lot in formulation technology. Spray dryer, freeze dryer, and fluidized bed dryer. There are a lot of other dryers also here. Like for example, you have a tray dryer, very simple equipment and generally used in preparation of granules and all. Simple mechanism. Then you have rotary dryer is there, rotary drum dryer, very simple equipment. Vacuum dryer also a little bit important and because we apply vacuum as we discussed in last class. Application of vacuum brings down the drying temperature. So thermolayable substances, so vacuum dryer plays a vital role. So these are the major equipments we are going to discuss. In the Mali Japamo, we will discuss today tray dryer, drum dryer, spray dryer, FBD, fluidized bed dryer, vacuum dryer, and freeze dryer. And ఇందులో చాలా చాలా ఇంపార్టెంట్ మళ్ళీ చెప్తున్నాను freeze dryer, FBD fluidized bed dryer, and spray dryer. ఇవి most important equipments you need to remember the principal construction and working. Let's see tray dryer. Very simple. You can see the picture here. ఏముంటాయండి ఇందులో ఒక ఫ్యాన్ ఉంటుంది టు సర్క్యులేట్ ద హాట్ ఎయిర్ and you have trays. So in these trays, what will happen? We will place the material to be dried. So simply by closing the equipment, adjusting the thermostat, we will place the material. So hot air will be circulated on the trays and heating is taking place. So simple. So you can see the principle. In tray dryer, the trays are loaded with the substance to be dried are subjected to hot air circulation continuously because of the fan. Moisture is removed from the surface by forced conventional heating. As a result, the moist air gets partially removed. So ఇక్కడ principle లో important ఇక్కడ forced conventional heating because of circulating the hot air. This is the point to be remembered. That's it. So specifications construction law, we can see that like approximately 3 trays are generally used to 20 trays data ఉంటాయి. Tray sizes can be like bigger in industrial scale. Each tray is rectangular circular shape like 1.2 to 2.4 square meters. Loaded can be loaded by 10 to 100 depth. And this distance between the bottom surface of the tray, upper surface of the loaded can be loaded up to the 40 also. So this is the general specifications of construction. No need to focus more on it. Now, what to be remembered here is hot air circulated by the fans at the speed of 2 to 5 meters per second. This is the point to be remembered. And contact time and the amount of water fixed in the single phase is 80 to 90% of water can be removed. And 10 to 20% of the fresh air is introduced in this ట్రే డ్రైయర్. సో ట్రే డ్రైయర్ లో పెద్దగా గుర్తుపెట్టుకోవాల్సినవి ఏం లేవు. ఫోర్స్డ్ కన్వెన్షనల్ సర్కులేషన్ ఆఫ్ హీట్ ఎయిర్ is the important principle here which is used for drying. So it's a conventional and over method. It's going to take a lot of time. Depth of the drying is more. See 40 దాకా 100 దాకా డెప్త్ ఉంటుందంటే లోవర్ లేయర్స్ స్లోగా డ్రై అవుతాయి. దట్ ఇస్ ద మేజర్ ప్రాబ్లమ్. Uses used in drying sticky material, greasy material, used in drying crystalline material, granular masses, used in drying plastic substances, used in drying wet mass preparations and paste, used in drying crude drugs, chemical powders, tablets, granules, especially it's used, and picking up of water and a following material, and it's also used in certain drying equipment. So granular material, sticky material, crystalline material, preparation of powders, tablets, and granules, and good uses. There are a lot of demerits, like I said, time consumption is the major problem. Second, loading and unloading material demands lot of labor. So time and energy is lots of time and energy is consumed during using the tray dryer. So clear with the tray dryer? No one? No one are clear with the tray dryer? Chandra, Deepika Chandra?
Yes, sir.
Okay. Then very important drum dryer. ఎంతమందికి దోశలు వేయడం వచ్చే వాళ్ళకి ఈ డ్రమ్ డ్రైయర్ గురించి తెలియాలండి. ఈ డ్రమ్ ఈజ్ నథింగ్ బట్ యువర్ హాట్ pan or in the form of a drum. Local I am sending steam to heat the surface of my drum. Now I am rotating this drum in a liquid slurry which I was supposed to be dry. So what happened, ఈ డ్రమ్ ఇలా రొటేట్ అవుతున్నప్పుడు పైన మనం దోశల పెనం మీద పిండేసినట్టు దీని మీద లేయర్ వచ్చేస్తుంది. ఇలా లేయర్ వచ్చేస్తుంది. ఆ లేయర్ ఇక్కడ పైకి వచ్చేసరికి దోశలాగా డ్రై అయిపోతుంది. ఈ స్క్రాపర్ దాన్ని స్క్రాప్ చేసి పక్కకు పడేస్తుంది. సో ఆటోమేటిక్ దోశ వెండింగ్ మిషన్ తయారు చేయొచ్చు. ఈ ఎక్విప్మెంట్ గురించి తెలుస్తుంది. It's so simple, very easy. You're taking a drum and drum lopala, you're sending steam inside the drum so that this surface of the drum is heated up. This drum is continuously rotated in the material to be dried. So a thin film of material is formed on this drum, and because of the steam present in it, it's dried. Then a scraper blade or knife scraps the dried surface. This is the drum dryer. Sala easy. It's developed in 1990s. You can see here, and it's used for the liquid food material before spray drying. Drum drying, a thin layer of chapana of a liquid or a slurry is spread over the surface of revolving drum, and the drum is heated by using steam. After 3/4 of revolution from the feeding point, the product is dried and removed using the scraper. This is drum dryer. Energy efficient drying method and efficiently dries highly viscous and poured material or poured food material. Okay, now this is about drum dryer. Very simple and very easy అండి. సో గుర్తుపెట్టుకోవాల్సింది ఏంటి అంటే ఇక్కడ చూడండి డయామీటర్ అండ్ డైమెన్షన్స్ ఆఫ్ ద డ్రమ్ 0.6 to 3 meters in diameter, 0.6 to 4 meters in length. 4 meters length, 3 meters diameter. మన వాటర్ డ్రమ్ ఉంటుంది కదా ఇంట్లో పెద్ద డ్రమ్ములు దానికంటే కూడా వెడల్పు ఉంటుంది. 4 meters హైట్ ఉంటుంది, 3 meters diameter ఉండొచ్చు. అంటే 3 ఉండాలని లేదు, 0.6 నుండి 3 meters దాకా ఉండొచ్చు. So this is the dimensions of the drum. And the external surface of the drum is smoothly polished because in order to form a thin film. So the feed pan is kept below the drum in such a way that the drum partially dips into the feed. So that the drum rotate అయ్యేటప్పుడు feed లోకి dip అవుతుంది. ఐఎమ్ మార్కింగ్ ఎల్లో మార్క్ యూ కెన్ సీ ఇక్కడ దాకా డిప్ అవుతుంది, అందుకే దాని మీద థిన్ లేయర్ ఇలా ఫామ్ అవుతుంది. దిస్ ఇస్ డ్రమ్ డ్రయర్. ఓకే, very simple. Come to the uses. It's used in preparation of dry solutions, slurries, and suspensions. Used in preparation of milk products like milk powder, starch products, ferrous sulfate suspensions. Used in preparation of zinc oxide suspension, kaolin, yeast, pigment, malt extract, and antibiotics, granular extracts, insecticides, especially DDT preparation, and calcium and barium carbonate preparation. Lo. Ante cosmetics lo, food industry lo, generally we are using this drum dryer in drying solutions, slurries, and suspensions. Products like milk products, starch products, ferrous sulfate suspension, zinc oxide suspension, kaolin, yeast, pigments, and extracts of other antibiotics and granular products. No, we are using drum dryer. What is the limitation of drum dryer? A lot of demerits are there. Its maintenance cost is too high. One of the limitations. Next, salt solution with less solubility cannot be dried. Next, feed rate, film thickness, speed of the rotation, and temperature can be controlled only by a skilled operator. If the operator is not skilled, if the operator is not talented, then he cannot control these parameters. So rate of the feed, film thickness, speed, rotation, temperature can be controlled by a skilled operator only. So that thing should be remembered. Okay, these are the merits, demerits of drum dryer. So we have seen tray dryer, we have seen drum dryer. Quick revision, tray dryer is used for sticky material, greasy material, plastic material, wet mask material, paste-like material, right? Yes, tray dryers. Whereas drum dryers అండి highly viscous material అని చెప్పుకున్నాం. డ్రమ్ డ్రయర్ అవునా? See, slurries, suspension, viscous material, milk products, starch products, and other major difference. Okay. Now, today's very important concept, spray dryer. పేర్లోనే ఉందండి, we are spraying our liquid to dry. This is called spray dryer. The method of spray drying is used for drying many thermally sensitive, thermolabile substances in food and pharmaceutical industry. This method involves rapid drying of the liquid slurry with a hot gas to produce the powder. So in spray dryer, you can see this equipment. Simply the product is sprayed through this nozzle in this big cylinder where hot air is circulated. When these liquid particles are sprayed, before they touch to the surface of this container, they are going to be converted into a dry product or dried into the product. And these fine products are separated using cyclone separator. So in spray dryer low, there are a lot of important equipments like liquid feed, atomizer for the spraying, right? And tangential inlet of the hot air so that centrifugal force can be created, right? And a peristaltic pump which continuously feeds the material to be dried. And very, very important, size separator by cyclone separator in spray dryer, right? So this class will end in like less than a minute. Please join back with the same link so that we can start discussing spray dryer clearly.